This is a machine that weighs more than 6,000 tons, costs up to $25 million, and moves slower than a person walking to their car in the rain, and without it, the modern city simply does not function. Tunnel boring machines, TBMs, sit behind nearly every subway tunnel, an underground rail passage built in the last 50 years. The global average cost of a subway tunnel runs $252 million per kilometer. In New York City, that number has climbed to $4 billion per mile, more than 11 times what the rest of the world pays. 3 questions worth answering. What happens inside one of these machines? Why digging a hole costs $1 billion? And what happens when it all falls apart? At the very front sits a massive rotating disc called the cutter head, ringed with steel disc cutters that grind through whatever the earth presents. The broken material, crews call it muck, gets scooped into buckets, dropped onto a conveyor belt, carried to the rear of the machine, loaded onto a small internal train, and hauled out. Right behind the cutter head, a robotic arm with a vacuum grip picks up precast concrete panels and locks them into place, building the tunnel wall in real time as the machine moves forward. The rear section stretches over 300 feet, carrying power systems, ventilation, and control rooms. Running the whole operation takes up to 25 people per shift, sometimes around the clock, and on a productive day, the machine covers about 40 meters. Even on a well-maintained TBM, only 30 to 50% of operating time goes toward actual digging. The rest goes to maintenance, repositioning, and logistics, because these machines aren't built for speed. Precision is what they're built for. Distinct TBM types exist because ground conditions vary wildly between projects. Hard rock machines grip the tunnel walls and drive forward using hydraulic rams. Earth pressure balance machines hold pressure at the digging face so soft urban soil above doesn't collapse, critical when the street overhead carries buildings and people. Slurry shield machines handle extreme water pressure by mixing excavated soil with a liquid called bentonite and pumping it out to a surface separation plant. Double shield machines toggle between modes depending on what the ground delivers mid-project. The dominant manufacturer started in a small town in Baden-Württemberg in 1977, when Martin Herrenich built what is now Herrenich AG -5,490 employees, more than 60 locations worldwide, and €1.88 billion in 2020 for revenue. Built almost entirely on boring through earth, a smaller machine runs up to €11 million, scale up to 15 meters wide, and the price reaches $25 million. When a project wraps, Herrenich frequently buys the machines back, refurbishes them, and sends them to the next job somewhere else in the world. London's Crossrail came in around $500 million per mile, and the rest of the developed world generally builds underground rail for about $350 million per mile. New York's numbers exist in a different category entirely. 2nd Avenue Subway Phase 1 landed at $2.5 billion per mile. The New York Times called it the most expensive mile of subway track on Earth in 2017. Phase 2 projections sit close to $4 billion per mile. And the planned 1.6-mile Harlem extension carries an estimated bill of $6.3 billion total, which researchers at NYU's Marin Institute called the most expensive subway extension in recorded history. That works out to roughly $62,000 per projected daily rider. The reasons aren't mysterious. Environmental review processes account for nearly 45% of total U.S. project cost. The 2nd Avenue subway was first proposed in the 1950s. Meaning the idea sat on paper for 60 years before ground broke. Legal fees, insurance, and project management costs balloon well past what other countries pay. MTA officials once noted that manually digging a 120-foot tunnel section ran nearly $1 million a foot, while a 3-mile TBM board stretch on the same system came to $19,000 a foot. Same city, same subway, 60 times cheaper. July 30th, 2013. Boring began on Seattle's Highway 99 tunnel using the largest TBM ever built at the time. 57.5 feet wide, 6,700 tons, assembled from 40 pieces shipped from Osaka, Japan, for $80 million. Workers named her Bertha, after Seattle's first female mayor. She had a pre-programmed melody that played inside during operation, and more than 5,000 people showed up to her dedication. Alongside the governor of Washington, the plan called for the tunnel to be finished in 14 months. On December 6, 2013, after tunneling 1,019 feet, 11% of the total distance, Bertha stopped, an 8-inch steel pipe, left underground by one of the project's own research crews and never logged on any map, caught in her cutting teeth, cracked the main gear, and destroyed the bearing seals. 2 years of rescue operations followed, a deep underground access vault, workers descending manually to the damaged machine, and the 4 million-pound front section physically lifted to the surface. For repairs, boring didn't resume until December 22, 2015. Seattle Tunnel Partners blamed the state and demanded more than $600 million. Washington's attorney told the jury the pipe had been no more significant than a toothpick relative to a 57-foot cutting disc. A jury sided with the state in December 2019, awarding $57.2 million to Washington, even as estimated damage to the machine itself reached $642 million. The tunnel opened February 4, 2019, roughly 3.5 years late, and now carries 80,000 vehicles per day. Swiss voters approved the Gotthard-based tunnel in a 1990 referendum, asking ordinary citizens to fund what would become, 20 years later, the longest and deepest railway tunnel in the world. The finished tunnel runs 57 kilometers through the Alps, reaches to 1,450 meters below the surface at its lowest point, and sits in rock that hits 46 degrees Celsius without active ventilation. 9 of the 2,600 workers who built it didn't survive to see it open. Total cost, $12 billion. For Heronic TBMs handled 80% of the tunneling, each one over 441 meters long. Built from 90,000 parts, priced at around $21 million each in 2009. One of them, named Gabby 2, drilled 56 meters of alpine granite in a single 24-hour period. When the tunnel bores finally met in the middle, the two faces were off by 4 millimeters horizontally and 8 millimeters vertically. After kilometers of blind drilling through solid rock, the margin of error came out smaller than a human thumb. Passenger trains now cross the full 57 kilometers in 20 minutes at 200 kilometers per hour, and the tunnel pulls the equivalent of 1 million trucks per year off alpine roads and onto rail. That is what this technology delivers when the planning holds. Tunnel boring machines don't make headlines until something breaks, and even then the coverage fades fast. These machines move at a crawl, cost extraordinary sums, and the people operating them spend their shifts inside a metal tube, advancing a few dozen meters at a time. And they are the direct reason cities like London, Tokyo, and New York can move millions of people underground without cracking the surface above. The distance between a Gotthard and a Bertha, between $19,000 a foot and $1 million a foot, almost never comes down to the machine. It comes down to a research crew that forgot to log a pipe on a map, or a subway line that spent 60 years in planning before anyone touched the ground. Somewhere under the street you're on right now, there is a reasonable chance one of these things is already moving, already building the infrastructure the next generation of the city will depend on for millimeters off course at best.